Hi, this is Mr. West, and today we're doing a multiplying/dividing fractions and mixed numbers Kuta worksheet tutorial. We're going to start with some kind of notes, if you will. Now, if you're interested only in the division part of it, you're going to want to skip ahead, and I'll go over the division section separately. So for multiplication, though, we understand if we're multiplying positive and negatives, this is the chart we need to understand. So we have positive times positive is a positive. We knew that. If we have one of those numbers as negative, then it's going to be positive times a negative is a negative for both those instances. And then this has to be different. So if we have two negatives, then it's going to be a positive. So these are just something to reference. Also with multiplication, it's pretty simple. It's way easier than division, and it's easier than addition. Is we have top times top, bottom times bottom. You're going to multiply the two numerators together and then the two denominators. Now, I'm going to get to this actually in a little bit later once we convert mixed numbers. But this is something, and then I'll also get into simplifying. Okay, so let's go ahead and start with number one. So with number one, all we have to do here is number one, understand our rules. So our rules are if we have a positive times a negative, it's going to be a positive. Now, obviously with positive numbers, we don't just put that plus sign out in front, but I'm just letting you know that we're going to have it's not going to be a positive result. We're going to have a negative result because we have a positive times a negative. Let me flip that. We have a negative times a positive, and that's going to give us a negative. So that's going to give us a negative answer. So now we just multiply the top times the top number and the bottom times the bottom. So we're going to do 5 times 1 on the top and then 4 times 3 in the bottom. So we get 5 and then over 12, and I like to put that negative sign out in front, and there's our answer. Now, we always got to check to see if we can simplify. In this case, we can't simplify because the top and bottom numbers do not have any common factors, so we're done. Let's look at number 2. So number 2, we have 8 times 7 in the top and 7 times 10 in the bottom. Now, for those of you in advance, you're going to notice that I'm kind of taking a long way about it, but I'm going to show you that there's a process to this. So I have 56 in the top and 70 in the bottom. Okay, so that's what happens when I multiply, but you're going to notice that I have a common factor. So that's the rules for simplifying. If we have a number, a fraction, and we can have a common factor between the top and bottom number, we need to divide by the GCF, which is the greatest common factor, and that will give us the most reduced form. So the greatest common factor in this case is 6. So we're going to divide the top and bottom by 6. Let me move that over. And we get our most simplified form. So in this case, it would be 3 over 2. Okay, in this case, we have a greatest common factor. And sometimes if you don't know, you can always just test out some numbers. So I'm going to recognize that I have a 7 in both these numbers. So I'm going to divide by 7, and I get 8 over 10. But that in itself is not even reduced all the way. I can divide the top and bottom by 2, and I get 4 over 5. So in this case, my greatest common factor should have been 14, but 4 over 5 is my most reduced form. Let's do a few more of the multiplication. Let's do number 5. That one's got a whole number. So if we're looking at number 5, I'm going to change colors here. So number 5, we have negative 2 times 3 sevens. So our first thing we want to do is we want to say, okay, negative times a positive, well, that's going to give us a negative. So we know our answer is going to be negative. Now, here's the issue, is it doesn't look like we have a top times times bottom because this is not expressed as a fraction. So we want to express it as a fraction first, and you can make it into a fraction, any whole number that is, or integer, by putting it over 1. So negative 2 over 1 is the same thing as 2. It just looks different, and now we can apply our rules. So now we're going to get a negative, and we're going to have negative 6 over 7. Oops, I put 2 negatives in there, and this is going to be our answer. I can't reduce it because 6 and 7 do not have any common factors, so negative 6 sevenths is our answer. So anytime you have a whole number or integer, you want to put it over 1. Okay, so this is the next part. So number 6, we have 2 mixed numbers here. So the first thing we need to do is we need to change them into improper. So that we do that by first multiplying the whole number times the denominator. So those two things, and then we're going to add the numerators. And that will change this to an improper fraction. We're going to keep the bases the same for both of them. So we know this is going to be over 3 and this is going to be over 10. And we're still going to multiply it, and we're still going to have a negative. So if I do 3 times 2, I get 6, and I add the 2, I get 8 for my numerator. So I'm going to have 8 because that was 6 plus 2, and that was 8. Then I have 4 times 10 is 40, add the 1. So I multiply these, add the numerator, and I have 41 in the top here. Whew, this is a big number. So a couple things with this. One, you can do something called like cross-canceling or cross-reducing. I know that 8 and 10 have a common factor of 2, so I'm going to divide both that and that by 2, and so I get 4 over 5. That's going to make my numbers a little bit smaller, but I still need to multiply these big numbers together. So I'm going to have 41 times 4. Well, I know 40 times 4 is 160, so I'm going to have 164, negative 164, over 5 times 3, which is 15, and they don't have any common factors because it already cross-reduced, so negative 164 over 15. If you're going to multiply 41 times 8 first, you'd be able to divide by 2 when you're done. So we would have 8 and then 32, 328 over, what is that, 30, and you'd be able to divide both those numbers by 2 to get the same answer right here. Okay, so those are equivalent. So that's all I wanted to do on this side. If you have any other questions, make sure to leave a comment and I can help you with it, but that's a good understanding, and we went through a lot of things. Now, moving on to division. I said if you wanted to skip ahead to division, here are our division rules. So it's the same thing. So if we have positive divided by positive, of course that's positive. And then obviously positive divided by negative can't be the same thing. So these are our positive divided by negative rules. And then negative divided by negative can't be the same as positive divided by negative. So that ends up being positive. So very similar to multiplication. Now, here's the second step. It's different, right? It can't be the same as multiplication. So how is it different? Let's take a look at 10 over 5 divided by 2. Well, first off, we know that this is equal to 2, okay? So that's why I put this 2 right there. And then we have this part divided by 2. So we know that this answer should give us 1, right? 10 over 5 is 2 wholes, divided by 2. 2 divided by 2 is just 1, okay? So we know our answer should be 1. What happens if we, instead of dividing by 2, we multiply by 1/2? What do we get? Well, we do 10 times 1 is 10, and then 5 times 2 is 10. What does that equal? 10 over 10. Can we reduce that? Yeah, we can divide by the greatest common factor, which is 10, and we get 1 over 1, which is equal to 1. So we get the same thing, and that's not a coincidence. Therefore, if we have 10 over 5 divided by 2 over 1. Notice how I put it 2 over 1, okay? Anytime you're dividing or multiplying and you don't have a fraction, you want to turn it into 1. This is the same thing as multiplying by 1/2, okay? So notice how if I divide by a number, I am going to change it to multiplying by 1/2. See how those two numbers are related? You're going to see that the top is in the bottom and the bottom is in the top. So I'm going to change it to purple to make it more evident. See how it's flipped like that. And that becomes our division rule. So we're going to use keep, change, flip, or multiplying by the reciprocal. That's really what it is. So if you're in an upper left mathematics class, multiplying by reciprocal is the way to go, reciprocal. So we're going to keep, change. I think I spelled that right. So keep, change, flip is the easier way to understand it. So we're going to keep that first number the same. Oops, sorry about that. We're going to change this problem into multiplication. So let me show what this looks like. So we keep the first number the same. We're going to change it to multiplication, but we can't just multiply by 2 over 1. That's a different problem. We're going to multiply it by the reciprocal. So dividing by 2 is the same thing as multiplying by 1/2. And we get our 10 over 10, which we then reduce to 1. Okay, so that's how it works. We keep, change, flip, and then you apply multiplying rules, which is top times top, bottom times bottom. Okay, so now let's look at these problems, now that we're ready. So here we see we have a division problem, and we're like, oh man, what do I do with division? This seems so strange. Well, we are going to keep, we are going to change, and we are going to flip before we start this problem. So we're going to keep the negative 1/5 the same. We're going to change it to a multiplication problem because we're familiar with those rules. Those rules are easy. And we're going to flip the 7 over 4 to be 4 over 7. And now we're ready. So we have negative 1 times 4. That's negative 4 over 35. They don't have any common factors. I'm done. That's my answer, negative 4 over 35. Let's look at this one. Two negatives. So this is our first negative times, negative divided by negative or negative times negative. We're going to end up with a positive answer, okay? So knowing that, I know my answer should be positive. Again, we are going to keep, so I'm going to keep that negative 3 over 2 the same. I'm going to change this division into multiplication, but I can't just do that without changing the problem how it looks. I'm going to flip. So I'm going to flip this into 7 over negative 10. Now, here's the deal. That's why I want to do this problem, is anytime there's a negative in the bottom, though, I can just change it to the top. It doesn't change it, but it makes it way easier in terms of handling these problems, okay? You have less work if you always keep it in the top. Okay, now that I'm done with setting up my problem, now I just pretend this is a multiplication problem. There's no common factors in the top and bottom, no cross-canceling. So negative 3 times negative 7 is a positive 21 over 20, and there's my answer. Let's do one where we have, there we go, there's a whole number. We should be familiar with this. We're going to keep, change, flip. So we keep this the same. We're going to change it to multiplication, and this is really 2 over 1. Always change it to a fraction. So when I multiply and flip, it's going to be 1 over 2. So I have negative 9 over 10 as my answer for number 15. Let's do one like this, and let's make this our last one. Other ones, you're just going to have to do some other improper fraction conversion. No big deal there. You should be familiar. So I'm going to multiply those two numbers, because that's the first step, is we want it to be all improper, and I'm going to add that 5. So we have 27 plus 5 is 32. Make that negative 32 over 9 divided by 3. Now I need to keep, change, and flip. So I keep this the same, negative 32 over 9. I change this to multiplication, but I can't just multiply by 3. That's ridiculous. That'd be changing the problem. Instead, I make it 3 over 1, and I flip it to be 1/3, just like that. 32 and 3 and 32 and 9 don't have any common factors, so I could just go ahead and multiply negative 32 over 27, and there's my answer. That's all there is to it. So I hope you guys enjoyed this video. Make sure to leave a comment, like I said, if you have any questions, and I look forward to seeing you next time right here on Wes Explains Best.